Yes, so before going further into the classes, let me introduce about myself. I'm Chaitanya. I will be your trainer for the next couple of next 20 days. Now 20 working days, and now well, coming back to my professionality, I'm a working professional. I'm working as a DevOps engineer, senior DevOps engineer, and as well as I have my certifications with Microsoft, Linux, and AWS. These are my certifications which I am having. And while you coming back to the next things, so I previously worked for so many companies. There are some. I have total 13 years of experience in all over the companies. So that is about myself and introducing about myself. Now let us go into the concepts of Docker. So why we need to go for the Docker? What are the prerequisites? So what we are going to learn here is Docker and Kubernetes. So these are the things that we are going to learn. And here, while learning about the Docker and Kubernetes, we are going further. First of all, what are the prerequisites to understand? Okay, so before understanding the prerequisites, I just want to understand about I just want to know about you. What is your capability and what are your learnings and why you are joining this session. So yes, anyone, you can start from your end. So why Docker and Kubernetes? Why you want to learn about this Docker and Kubernetes? Have you ever had any experience in any cloud technology? I just want to know about yourself. Yes, go on. Yes, guys, I just want to hear from you.
Yes, I am Abhishek actually.
Sorry.
Yeah, is it audible?
Yeah, you are audible now.
Yeah, yes. So actually, I am Abhishek. So my
Mm-hmm.
experience is into the backend developer actually. So
Mm-hmm.
since Docker is a new thing actually happening for us, like whenever we are actually going for any distributed environment, like
Okay.
having instance of our application into some distributed application. So Docker is right now actually is happening for us.
Mm-hmm.
So and Kubernetes as well. So in
Okay.
some field. So that is the only reason actually I wanted to know a little more about Docker and Kubernetes because it is very new for me actually.
Okay. So it is a new and you want to learn about Docker and Kubernetes. Okay,
Yes.
that is great.
So yeah. So
Mm-hmm.
internal things also will be, I think, useful for me, and at the same time, like I will also need to explore like how our application will be uh, like available into the distributed environment like Docker and Kubernetes.
Okay, I understand your concern. Then
Yeah.
yeah. So now any another want to share why you want to learn Docker and Kubernetes?
Hi,
Okay.
Chaitanya.
Hi. Hi.
Myself, Ramesh. So, I am working as a backend Node.js developer from 2 years.
Mm-hmm.
Having 3 to 4 years of experience.
Mm-hmm.
So, because the learning again, because I want to explore the more and more about the Docker and most today's was deployment on the Docker images
Okay.
and how the deployment is going, how the business span of the time application is down, how to trigger the new applications with the new yeah, with backend, you know that with backend capabilities like logging, monitoring, everything which comes inside the DevOps activities. So
Okay.
possibly the reason exploring the most of Docker's its internal components like as well as the Kubernetes.
Mm-hmm. So good. So very happy to hear from you. Yes, when we coming back to the next one, that's all. So if you want to introduce about yourself, I don't have any problem with going further. Let us go with the prerequisites. What are the requirements to understand the Docker and Kubernetes? Here, especially, we don't have any special prerequisites, but only one prerequisite is that you need to have any one of the cloud knowledge. Cloud knowledge in the sense is that mandatory to learn Docker and Kubernetes. Sorry, to understand Docker and Kubernetes, do we need to have any cloud knowledge? I'm not saying that you need to have the very in-depth analysis of the cloud AWS, but yes, why I am saying this is because when we are going to configure this Docker, we need to install Docker on any one of the server. Install. So we are going to install this Docker on a server or else on an EC2 instance. So at least you need to have a basic knowledge of the EC2 instances. So how EC2 instance will be configured in AWS. If you have that knowledge, we can clearly understand about the Docker and Kubernetes. Okay, so whatever the clusters that we are creating in Kubernetes or else whatever the servers that we are creating in Docker, each and everything we will be creating on the EC2 instances only. So especially I am going only with the AWS configuration. So if you have a basic knowledge on AWS, that's more than enough. So I'm not saying that definitely you need to have that, but if you have a basic knowledge, that's very good. You can clearly understand about what is happening in the backend. Now, when we coming back to the again next thing, is there any further requirements of is there any further requirements to understand Docker and Kubernetes? There won't be any further requirements. Just the basics of AWS is more than enough. For that, you can go for any video in the YouTube. Just you need to understand how we can create EC2 instances. What is an VPC? If you understand that, that's more than enough for us. Now, do we have a Linux knowledge? It is not what I can say. I am not saying that you definitely need to have this knowledge. Basic knowledge if you have, that's more than enough. So Linux is, yes, of course you need to understand Linux. If at all, if you are if you are going to expose for more and more of what I can say DevOps in the DevOps times, like right now we are not going to use Jenkins. Especially in Jenkins we have to write Jenkins files by using the uh, Jenkins files. Inside the Jenkins files we will be going with the some shell scripting concept. So we don't want any Linux right now. So in Docker and Kubernetes especially, we don't want the Linux understanding. The basics is enough. And when you coming back to the next one, what is the most important thing that you need to understand here is understanding YAML is important. So ain't markup language, how we need to write the YAML script. YAML is a scripting language. You need to understand basic knowledge about YAML, which I can provide you that. So whenever I am saying you about something, definitely I will explain you about how to write some scripts in the YAML. So after understanding that scripts only, we are going further into the concepts. So I'm not saying that you need to have a mandatory knowledge on YAML. If you don't have knowledge on YAML also, I will be including YAML in our sessions. Whenever we are discussing about this, I will include that so that you can get a clarity. Why we need to understand this? Why we need to understand this YAML? Because in Docker, whenever we are writing some Docker compose, there is a concept called as Docker compose. We will be writing that a Docker compose in YAML only. So we don't need to go in depth into the Docker compose. Why? Because Docker compose will be written by the developers. But anyways, if you want to understand, I can tell you about the Docker compose. It is not a very big deal to understand Docker compose. But only the problem is whenever we are understanding about the KTS, the Kubernetes, in Kubernetes, we will be creating each and every resource with the manifests only. So we are going to write some Kubernetes manifest. So to write this Kubernetes manifest, we need to have a basic understanding about the YAML scripting. So every resource, if you want to create a pod, if you want to create a cluster, if you want not about the cluster, if you want to create a pod, if you want to create the deployment, if you want to create the resources, the replica sets, or else any small resource you want to create, you will be going for the status manifests only. So in the declarative format, we are going to write them. I am not scaring you. It is a very simple language or else simple scripting language. It is not very tough to learn. It is just a simple language that we are going to learn. I will explain you how to write the YAML script. It will be very easy to understand. So you don't need to worry about that. So these are the prerequisites that you need to understand. And when coming back to the next one, why Docker? Okay, why Docker and what is Docker? Okay, what is Docker? Why Docker? And how we will be working with the Docker. These are the things that you need to understand. And next one is what is Kubernetes? You need to understand this also. First of all, you need to understand we are not going into the Dockers. Try to understand one thing. Docker is a company name. Just focus on this. Docker is a company name. So like Docker, we are having separate concepts also. But here, whenever we are going into the concept, we are learning about containers. Okay, containerization or containers. So especially you need to understand what is this container. If you understand what is this container, you can come across the Docker also. Docker is like an engine. It is an engine which will be carrying out your containers. You will understand this very in depth when we go into the Docker. But before going into the Docker, let me explain you a very small scenario so that you can understand what is Docker. So if you go backwards, not into the right now, we are into the latest generation of IT industry. I am not working with the latest generation of IT industry. If at all, if I am going back in from 10 to 15 years. So if I go back some 10 to 15 years back, then what we are going to do here is we need to understand we need to understand one thing. So before Docker or before Kubernetes, before virtualization, what we will be having. So for that, I am having a small presentation so that you can get clarity here. Okay. So do you have the clarity about this prerequisites? Any questions, guys? Any questions about this prerequisites? Anything that you want to ask me? Can I go further? Okay. So let us go back. So yes, let us discuss about this. It's not a very in detailed concepts of this Docker. So, but I just want to introduce about why we are going for the Docker. So before when we are entering into the Docker, before we go into the virtualization, previously in the good olden days, we used to have we used to have physical servers. Good olden days in the sense when we go back 10 to 15 years back, we are having only physical servers, and these physical servers, see what is a server. All we are all know, we are all the working professionals, we know that a server is a component which will be having its dedicated resources. It will have RAM, CPU and storage, and we can work with those servers. We can install the application and serve the customer needs. So why we need to have those servers are utilized for serving the applications to the customers or else serving the applications to the clients. Okay, so outside people, for example, there is a banking application. Why we will develop the banking application? To provide access to our clients so that they can access their banking accounts very easily. So how we are going to provide that? Obviously we are going to develop a banking application and we will be deploying that on the server so that it will be accessible for the outside people. So in the same manner, this is the reason why we are going for the servers. But what is the problems with the servers? So if you can see here, the servers are located in the company. Inside our company, we will have a server room. Okay, inside that server room, you can have your servers. or else these servers are available in a huge range inside the data centers. There is a very big data center that is available. So inside the data center, we can have multiple number of servers, not single server. So we don't find two, three servers. There will be some hundreds of servers are available in the data center. So either a company can have its own servers in the server rooms inside the on premises, or else the same company can have the servers in the what I can say data center. So they can go and get a contract from the data center. They can purchase their own servers. Right now, whenever I am working for one of my company, right now I am working for a company where we used to have our own servers in the ground floor only. We are residing in some third floor, and our servers will be in the ground floor only. So that is what. So we have some 16 to 17 servers that we are coped up with. So I can communicate, I can go down. So I work as a DevOps engineer, as well as I'm working as a system administrator also for the company. I need to configure the Active Directory and all the things. So that is what. So a server can be residing within the company, within the on premises, or else it can be in the remote location called as data center. Now, the next one, what they are saying is, so it runs the operating system directly on the hardware and provides the computing resources such as processing power, memory, storage to support various applications. Now, the main problem is physical servers. Whenever we are working physical servers, they can easily work out with the applications. So what they are saying, physical server is typically assigned a specific task or workload, such as hosting a website, running the database, or serving an application server. So if you see here, we are having three types of servers. We are having three types of servers, especially whenever we are going for hosting a website. Okay, I will call it as three-tier architecture. So whenever you see what is this three-tier architecture, so three-tier web architecture in the sense, so there will be an UI server. There will be especially there will be a team called as UI team, or else there will be a developers, front-end developers, where they are going to develop their application. And next, and for that UI, you are going to configure some application. Either it might be a Java application or Python application, any application. We are going to configure an application. And then to store the data that is given by the users by using that website, we are having a database server. So this is the three-tier web architecture. When you see here, we will have a web server where our websites are going to be hosted. Okay, we are going to have a web server where our websites are going to be hosted. Hold on. Come on. Okay. And after that, when these web servers are configured, we will be having a application server. Application server, or it is the main business logic. So which means that how this web server has to work, whenever the user is accessing some URL, the web server has to respond for that user request. So those response will be provided, how this web server has to react for the user responses, or else user request will be given by this application. So this is called as your application server. And later on, you will have a database. Whenever user want to store some data, so that data will be stored inside this database server. Now, if you can see, all these three can be configured in a single server, or else all these three will be configured in the multiple three different servers. So either it can have the web server in a web application in one server, and then it can have the business logic. So related to this web application, it can have the business logic or else application in the another server. And then especially the databases are not going to configure in the same servers. So every company will have their own databases, and they will be secured, and they will store in a very secured places. So maximum number of companies will contain their databases in the separate manner. So here, this is how your three-tier architecture will be there, and that is what they are saying here. What they are saying here is physical server is typically assigned a specific task or workload such as hosting a website, running the database, and serving as an application server. These servers have a dedicated resources and operates in the isolation from another servers. Now everything is good. We can work with the physical servers. But what is the main drawback of physical servers is that physical server offers high performance and low latency. So why? Because they are directly accessible to the hardware resources. Whatever the applications that we are using, those are directly exposed to the hardware. So physical servers will provide high performance. Okay, so if you want to run any application, it is not going to consume more and more CPU and more RAM. But the problem is, only the thing is, underutilization of resources will be happening. So inside a physical server, either you can run a single application only. You cannot run multiple application. For example, there are two application as I am saying you here. For example, there is a server or else there is an application, and this application, when we are running on the single server, when I am running on a server, I may be require Java 8 version. Okay, for that application, I may be requiring a Java 8 version. If I want to install another application with the version Java 11, okay, Java 11, what I have to do? So Java 11 is the latest next version of the Java 8. So this application, for example, app1 is having a prerequisites to run that on the Java 8, and app2 having a prerequisite that should be running on the Java 11 version. So what I have to do to run app2, definitely I need to upgrade this Java 8 to Java 11. So I need to upgrade to Java 8 to Java 11. But the problem is, when I upgrade this, app1 will not be running. Okay, if I don't upgrade this, then app2 will not be running. So especially, so this is the main problem with the main physical servers. So on the operating system, either you can have a single version. If you want to upgrade the version, yes, you can upgrade it, but the application compatibility won't be there. So to overcome these issues, and not only this, so only one application will be running on the server. So whenever we are running a single application on the server, I cannot say that every time maximum resources are going to be utilized. Every time maximum resources are going to be utilized, I cannot say that. So what is happening here? A minimum utilization, sometimes there will be a minimum utilization. For example, I'm working with some stock market application. So NSE, BSE stocks. So whenever we are working with this NSE, BSE stocks application, the load on that particular application will be around 8:45 a.m. to 3:45 p.m. only. So after that, the load won't be there. Everybody won't be trading their stocks after 4 p.m. So the NSE, BSE stock exchange markets will be closed at 4 p.m. So the load won't be there after 4 p.m. and before 8:45 a.m. or else 8:30 a.m. So what about the rest of time? Rest of time there is no load on the server. The server can sit ideally. So this is the main problem, the underutilization. Sometimes there will be utilization, sometimes there won't be any utilization. And for example, let me take an example here. For example, if you are hosting an e-commerce websites like Amazon, Flipkart, or also any e-commerce website. So at that particular time, so whenever we are hosting this applications or e-commerce application, when we announce an offer, then only when the e-commerce websites announce an offer, then only there will be a huge traffic on that particular application. On general days, you don't find that traffic. So what about the resources? The resources will sit ideally only. They won't be working very fastly as they require to work on, and highly when there is an offers day, the servers will be totally, what I can say, totally working for the customers. But now as the offers are closed, there won't be any utilization of the resources. So underutilization of resources will be there. So that is what they are saying. However, they can also result in underutilization as individual server often run at a fraction of their capacity, leading into inefficient resource allocation and increased operational cost. So I am running only a single application. If I want a new application to be configured with the new versioning, then I cannot install that application on this server. So I need to go for another server cost. So if I want to purchase a physical server, it will cost around 3 lakhs minimum basic level of servers I am saying. And then what I need to do, so purchasing of server is not going to give you the solution. So when you purchase the servers, what else you have to do? So there will be an operational cost for this server. There will be some operational cost. What are the operational costs? You need to configure the network for that server. Without network configuration, we cannot make the communication with the servers. So we need to have a network configuration. And later on, we need to have, so when we purchase the server, we need to have one more thing, that is somewhere around, we need to monitor the server. We need to monitor the server 24/7. We need to have a monitoring team. For that, additional cost will be incurred. And then we are going for managing of servers. So what is this managing of servers? Every time the server won't be running with the same load on, or else every time the server won't be running with the same resources. At a particular time, what is going to happen? There might be a chance of damaging of some resources. The RAM will not be continuously running. Why? Because when we start the server, we will not at least reboot the server for 3 to 4 years. I have seen this. Whenever in a company, we used to work for a company there, I am having a Linux server, and that Linux server is not rebooted for 5 years. It is continuously working. It is continuously working. So when the servers are continuously working, there is a chance that some of the devices may be replaced. Maybe we have to replace some of the devices, so the management cost will be there. So this is about your operational cost. So how we can overcome this? So the first problem is underutilization, and the second problem is cost. So how we can overcome all these things? So to overcome all these things, IT industry has understand the problems with the physical servers. They have gone for a new concept called as virtualization. They have gone for a new concept called as virtualization. Now, did you understand about this physical servers? What are the problems with the physical servers? Any questions, guys? Any questions that you want to ask me? Okay, right. So let us go for the virtualization. Again, if you want to say anything, you can unmute yourself and you can say. So I don't want my class to be a single-sided class. I want my class to be a mutual communication class. You can ask me any question. I can, if at all, if it is very relevant to the topic, definitely I can explain you on that. It is irrelevant, then I can tell you, we will see in the end of the session. Okay, so you can ask me any questions if you have any doubts. So maintain a rough paper or rough notes. Don't sit ideally in front of your screens. Okay, see, don't sit ideally. It is not a movie that you are going to watch. It is a class. So take a paper or take a notes, a rough notes. Write down some points. Whenever I am saying, write down some points. That will be helping for you. If you have any question, you can ask me on that. Okay, fine. When we coming back to the next one, this is what the physical server context. When we come back to to overcome all these problems in the IT world, so the IT industry has gone for a new concept called as virtualization. See, this is the real-time scenario. See that, for example, let's say a company have 3 physical servers, each with 16 CPU cores. 16 CPU cores, which means this computer or else these servers are having 16 CPU cores, or else you can go for 20 CPUs also, and each and every, which means that, so all these 3 servers will combinedly have 48 CPU cores, and each server will have 64 terabyte 64 GB of RAM, 64 GB, 64 GB, 64 GB, which is equal to 192 GB of RAM. and 1 terabyte of storage with the traditional physical server deployment. If each server hosts a single application, this server is hosting, so for example, there is a banking application for SBI. So I will go with this server is hosting SBI banks, and this server is hosting some cooperative bank application. This server is hosting some XYZ bank application. Now three servers are hosting some application, single application. There may be an instance where the application only utilize a fraction of available resources. This could be due to the various variations in the application workload or period of low user activity. So this is what I'm saying, RAM and storage. So to overcome this problem by adapting the virtualization, what is going to happen? The company can maximize the resource virtualization. The company can maximize the resource utilization by running multiple virtual machines on each physical server. So we are going to take, and each VM operates an independent and isolated environment with its own virtualized CPU, storage, and network resources. What is this happens? What is this point is saying here is, whenever we are going for the configuration of virtualization, try to understand one thing. For example, I just want to give a simple scenario so that you can get a clarity. You are having a hard disk, or else you are having an SSD. Let us supposing you are having a hard disk, and this hard disk will be having a size of 1 TB. This hard disk will be having a size of 1 TB. Okay, so this is installed inside your computer. Now I don't want 1 terabyte size of this hard disk as a single partition. Okay, now what I want to do, I want this hard disk into multiple partitions, so that one partition will be of size some 200 GB. Okay, one partition, or else I want 5 partitions of this hard disk, like 200 GB and 200 GB and 200 GB, like this. So if I want like that, so what I am going to do here, am I going to break the hard disk into 5 pieces? Am I going to break the hard disk into 5 pieces? We are not going to break the hard disk into 5 pieces. But logically, we are dividing that hard disk into partitions, like 200 GB, 200 GB, 200. If you see, I am having 500 GB of hard disk. Now I just divided that 500 GB into two partitions. One is of some 225 GB and other is one is of 250 GB. So this is the logical partitioning. We are doing the logical partitioning, which means we are not physically breaking it into small hard disk. We are breaking that hard disk logically, virtually we are breaking the hard disk. In the same manner, here you are having a server. For example, you are having a server, or else let me take a very big one. So this is your server, and this server will have, somewhere like 16 CPUs. Inside your physical server you will be having 16 CPUs and somewhere like 128 GB of RAM. So these are the physical resources which I am having. So if I install a single application, then what is going to happen here? This single application may underutilize these resources. So to overcome that problem, what I have to do here is, on this server, I am going to install a virtualization. So there are two types of virtualization. So what are the types of virtualizations that I am having here is, so generally there will be a type 1 virtualization and type 2 virtualization. This type 1 is also known as bare metal virtualization. Bare metal virtualization, and type 2 is also known as hosted virtualization. Okay, so these are the two types of virtualizations which we are having, type 1 and type 2, in generally bare metal and hosted. So in the bare metal virtualization, what is going to happen in the back end? So bare metal virtualization, we are going to host, or else we are going to install some of the virtualization software. So which type of virtualization software that we are going to install? So the virtualization software like VMware ESXi, Okay, VMware ESXi, or else we can go for Citrix. These are the basics. Okay, Citrix Gen servers, we are going, Citrix is one of the virtualization component which we are going to install directly on the server. See what we will install. For example, if you need to understand, we will purchase a new computer. When we purchase a new computer, or we are going to directly run the application on the computer, what we are going to do we run the application directly on the computer, or else we are going to install anything else? So can you tell me about that?
You mean to say that you recently purchased a computer and you wanted to execute the program on this? Is it clear? Is it right?
Yeah, yeah, that is what I'm
Oh,
asking. If I want to run some applications, what I have to do?
operating system. We need an operating system, definitely.
Exactly.
Without
We we need an operating system. But if you want to run a virtualization software like VMware, ESXi, and Citrix, you don't need an operating system. Directly, you can it itself will run as an operating system. You can directly install this VMware, ESXi, and Citrix on your physical hardware itself. Okay, on the physical hardware itself, so that you can create your virtualized servers. So here you will have a virtualization software. This is your virtualization software. Okay. Uh, okay. So this virtualization software, why we are using this virtualization software in middle is, so if you want to create any servers, you need to have a hosting. So this server, something needs to understand the requirement. So if I want to create a virtual server on my physical server, then someone has to understand the needs of the virtualization. Someone has to understand the needs of the virtual server. This virtual server, if you want to create a virtual server, I want some 2 GB RAM, so or else 4 GB RAM, and I want some 2 CPU cores. If any server is executing like that, then what should be happened here? Someone has to understand the requirements. So who will understand this? Obviously this virtualization will understand that. So this virtualization software will understand the server requirements. Okay, the virtual server requirements. If I have to show you one thing clearly, let me show you. I am having a virtualization server here, or else virtualization software. So if you can see here, uh, let me show you one thing. Okay, here you can see I'm having a virtualization workstation pro. Okay, VMware workstation pro. If you can see, now what I can do here is, when we go back here, I can create a new virtual machine. So I just want to create a new virtual machine. So this virtual machine, whichever I am going to create, will specifically take the resources from my, so I want to install my Windows Server 2019, or else you can go for any Linux also. I want to install some Ubuntu machine. Next, and if you can see how much amount of storage you want. So hard disk space, I want 20 GB of hard disk space. Now this 20 GB of hard disk space is allocated from my physical memory, or else physical storage. Okay, from my hard disk. Next, if you can see here, so here you can see a server has been created. A Ubuntu server is created with the memory of 4 GB. If you want to increase this memory, you can increase the RAM size. You can increase to 16 GB or else 8 GB. My physical computer is having 16 GB of RAM. So from that 16 GB, so this server can utilize some 8 GB or 4 GB or 2 GB. That totally depends upon our requirement. So I can provide some 4 GB. And how many processors it is going to run? So it is going to take the processor cores. So only single processor with 2 cores. So dual core processor I am going to install on this server. Like this, it is going to, so who is communicating with my physical hardware? So if I want to run this if I want to run this virtual server, this virtualization, the VMware is going to communicate with my physical server requesting for the physical resources. Okay, so let me take an example. There is a family. Inside the family, so if at all, if I say a family, there will be father, mother, and there will be children. Now, children's one of the small kid is in the school and the other kid is in the college. Now, everybody, both the kids won't have the same requirements. One kid will have like whoever are going for the school, he don't require high money or else lot of money. So he just need the notebooks and he just need some school uniform and all the things. But nowadays it is very expensive for the small kids only when you compare with the kids, or else when you compare with the boys who are going for the colleges. So, but anyways, that is altogether a different concept here. But when you come to the next kid who is going to college, he will have his own requirements. Now, the point is, who has to fulfill this requirement? Obviously, the father has to fulfill the requirements. Now, whether the kids are directly going to the father and asking for money, they won't do that. So why? Because some kids might be directly going and asking their father, but majority number of the times, what happens here? They will go across the mother. So they will inform the mother saying that I have this particular competition or else I have this particular function. So I want certain money. So please ask a father for that money. So if the mother is so intelligent, she will abandon that. But some most probably mothers won't stop whenever kid require anything, whenever her children require anything. In the same manner, here also try to understand our physical server is like a father who is having actual resources, who like father who is earning for the home. In the same manner, so the physical server will have the actual resources. Okay, now when you come back to the virtual servers, these are like kids, these are like children. So one of the virtual server may require 2 GB of RAM and one CPU, and the other server may require some 8 GB of RAM with two CPUs. So these are the requirements of each and every server. So if depending upon the application that are running on the server, each server may require different resources. Now, how they will get from the physical server? Obviously, like I said, your mother is going to talk with your father in the same manner. So depending upon the requirements. So what is going to happen here? Whenever the virtual machine requires anything, so these virtual machines are going to communicate with the virtualization software. This virtualization software will communicate with your physical resources or else physical server and take out the physical resources. Now, this is what going to happen in the backend. With that, this virtualization is going to be installed. Now, if you can see here, I have a Ubuntu server running, I have a Windows Server 2019 is running, and I have a Windows 10 operating system is running, which means that I am running three different missions on a single system. Okay, so without any problem, I can run this. So each and every system. Now, if you see the diagram here, how that will be, if you can see, first of all, I will be having a physical server or else physical components like CPU, RAM, and disk space. On the physical component, if at all if we are using the bare metal virtualization, directly we are going to install some virtualization software like VMware and Citrix. Okay, VMware and Citrix. Okay, and then on that directly we are going to install or else directly we are going to run the virtual machine. Here I am running a virtual machine. Each virtual machine will have its own guest operating system. Here guest OS in the sense either it can have a Windows operating system or else this virtual machine will have some Ubuntu operating system or Linux operating system like Red Hat, CentOS, Fedora, SUSE, like the different flavors are there. Depending upon the requirement, we can run our guest OS. So inside the guest OS, you will have the kernel, and after that you will have some of the few components, and on the top of this we can run our virtualization or else we can run our applications. So on the top of your guest OS, you can run your applications. Okay. So in the same manner, you will have in the next slide also, you can have another virtualization server where we can run our app2. Okay, where we can run our application too. Okay, this is your basic virtualization concept. Here, this is how your virtualization will be looking like. So this is your hardware. And this type of virtualization is called as type 1 virtualization, or else I can call it as bare metal virtualization. Why? Because we are directly installing the VMware Citrix applications on the hardware layer only. So this is called as bare metal virtualization. Okay. Now there is another type of virtualization that is called as hosted virtualization. What is this hosted virtualization? So yes, this is the bare metal virtualization. When you're coming back to the next one, we are having a hosted virtualization. What it is going to do? Here it will be the same only, but the point is in between the VMware and Citrix, we are going to install our own host operating system. So on the host operating system, we are going to install the virtualization softwares. So here on the hardware, we are going to install our host operating system. Either it might be a Windows or Linux operating system. On the top of that, we are going to install the virtualization softwares. Okay, so this is how we are going to install the virtualization softwares. Either we can install the VMware, okay, VMware, or else we can go for Oracle VBox, VirtualBox, or else we can go for Linux KVM, kernel-based virtual machines. Like that, we are having several virtualization software. These are the examples which I am providing. On the top of that, we can install our guest OS. Now, can you tell me which type of virtualization I am using? This is called as a hosted virtualization. On my computer, which type of virtualization I am using? Either I am using the bare metal virtualization or hosted virtualization.
Hosted.
Exactly. We are using the hosted virtualization on my laptop. Why? Because here you can see I am having a physical resources. On the physical resources, I just installed my operating system. On the top of that, I am running the virtualization. On the top of that, I am running my guest operating system. So these are the two operating systems which we are using. So with the help of this virtualization, there will be a high utilization of resources will be there. Optimized utilization of resources will be there. Suddenly, for example, I am not saying that each and every resource, total resources are not going to be consumed. We are going to put some resources as a backup. Why? Because suddenly if there is any increment in the RAM utilization, I need to provide that. So I need to have the capability to provide the requirement for the server. So now if you can see here, the guest server is running. Suddenly, if the load on the server is increased, which means that I need to increase the RAM. Of course, I need to increase the RAM. How I can increase? So I need to have some backup of that RAM. So I need to have some certain RAM resources should be there. So without having, if I give the total RAM and the CPU for entire applications or else entire virtual machine, suddenly if the load is increased on the virtual machine, I am not able to provide that. So I have to check out the virtualization such that, so if there is any special load is there, automatically I need to provision the requirement of that virtualization. So I need to understand the scenario. Apart from that, you cannot provide your entire resources for the virtualization. Okay, that is the one point which you need to remember. So this is about your virtualization concept. And one more thing here is, whatever the servers that you are creating on the virtualization, each and every server will be in an isolated environment, which means that by default, these two servers will not communicate with each other. If you want, you can establish the communication. But what is the point that I am saying here is, if you want, by default, they will not share the resources. They will not communicate with each other. So isolated environment will be there. And one more thing here is, there is an option called as scalability. Suddenly there is an increasing in the RAM requirement. So we can check out the logs why there is a sudden increasing in the RAM, whether the application is malfunction, or else whether the application is having it due to any bugs in the application, the RAM is increasing, or else truly it is having heavy load. We can check out the logs. So in the logs, if at all, if we see that there is a heavy load is applied on the application, then we can communicate. Then with the help of, suppose if I am showing you this, let me show you one thing. So there is 4 GB of RAM. Simply I can increase that. At the running time only, I can increase the RAM utilization also. So I can scale my resources. I can scale up or scale down my resources, which means increasing or decreasing of the resources can be happened with the virtualization. But if you see in the physical servers, it won't be that easy. Inside this virtualization, it is very easy to increase and decrease the resources. But when you go for the physical servers, it is not such easy if you, when you compare both. Okay, so that is the reason most of the companies, not most of the company, each and every company right now are using the virtualization concept only. Okay, so I hope you understand about this virtualization. Any questions, guys? Understood about the virtualization?
Yes, sir. Actually, can you please go to that incident? So, sir, here actually for hosted virtualization, that Citrix component is not present, right?
Sorry, come again. Which component?
Yeah, Citrix.
It's Citrix. Yeah.
Yeah,
So
Citrix.
this is like, see, this is like your server components. Okay, so these are the specialized components. Like, especially I have to include, I have to say this. This is VMware ESXi and Citrix. These are directly bare metal virtualization components. Okay, but these are the client side components. Okay, so which will be working with the client side, VMware, VBox, and KVM. So Citrix, yes, it is not available. This is only for the bare metal only. Okay, if you want to run some hundreds of virtualization missions, you can go with VMware. It is like a server and client structure, you can understand. So on servers, you can run VMware ESXi and Citrix. On your client missions, like your laptops and desktop, you can go for the VMware, VBox, and KVM. Okay.
So, sir,
Yeah.
like what I just wanted to know, like like in bare metal virtualization, like what would be the use case to use for this kind of virtualization? I mean, if you compare with that hosted, actually.
In
So,
hosted, you will have an operating system. Here you can see
yes. So
Windows
that is
operating system.
yeah, that I understood actually. But
Mhm.
regarding this bare metal virtualization, like what kind of scenario will be there, like where we can go for bare metal over the hosted?
All the organization right now are using the bare metal only.
Okay.
In the companies, you won't see this hosted virtualization.
Ah,
Okay, this is not available in the companies. Each and every company will be going with the bare metal only.
hmm,
Okay, so this hosted virtualization is only useful for our convenience, for our development perspective. If you want, see why I need to install this VMware on my laptop to check out some applications, whether how they will be reacting with my development, if at all, if I am in the development mode, how they will be working. So to understand only in the client mission, I am using this hosted virtualization. Okay, so companies won't use this hosted virtualization. Company will be going with the whatever the organizations that you are working, they will be going with the bare metal only. Okay, each and every company will have this configuration only. Understood?
yes,
Yeah.
yes.
Now, apart from this, latest companies are not going with the bare, so they are working with the bare metal, but still we have an introduction to the Docker. So Docker is also, it is called as a software operating system virtualization. You'll come to know about the operating system. This is called as a hardware level virtualization, and we are next thing, the Docker and all the things will comes under the operating system level virtualization. You will come to know in that in the next class. Up to now, I hope that you are clear with the virtualization concept. If at all, if you are clear, in the next session we are going to discuss about the Docker, where we are about to start the Docker. And one more thing, only 3 demos will be there today, tomorrow, and day after tomorrow. Okay, Monday, Tuesday, and Wednesday. And from Thursday onwards, the link is going to change. We are going to complete the sessions within 20 working days. We have to complete that. And the sessions only for these 3 days or for this week, the sessions will be only for 1 hour. And from next week onwards, the sessions will be for 2 hours. So 6 to 8 will be the sessions. From next week onwards, the sessions will be covering from 6 to 8. But for this week, the sessions will be from 6 to 7 only. Why? Because at 7 o'clock, I am having another class. So I'm going to wind up that. That is also a Docker and Kubernetes class. Okay, so I'm going to wind up this, especially this is my, so if I have to say practically, physically, online and offline classes, offline I have taken some 15 Docker and Kubernetes classes for DurgaSoft, and this is my second online Docker and Kubernetes class for DurgaSoft. And apart from that, for the another institute, I have taken some 30 classes for Docker and Kubernetes. So overall, if you compare this, this is around some nearly equal to 50 sessions of Docker and Kubernetes. This is the 50th batch or else 47th batch which I am taking for Docker and Kubernetes. Okay, you don't need to worry about that. Yes. Anyways, going for the concept. So I have given you some clarity. Tomorrow I will explain you about the syllabus which we are going with the Docker and Kubernetes, and then we will be going with. So I hope you understand. So 20 working days, or else if at all if it is prolonged, some 5 working days also it can be prolonged. But majorly I have to complete this Docker and Kubernetes class. As it is a fast track batch, I'm going to cover it within 20 working days. Okay, am I clear with the timings and am I clear with the concept?
So sir, you meant to say that first week it will be the timing will be 6 to 7, and the subsequent weeks will be from 6 to 8, right?
Yes, exactly. 2 hours of session will be there. Okay. Any further questions, guys? Chalo then. Let us wind up the session. So that's all about my Docker and Kubernetes. Just that is about the introduction to the virtualization. In the next session, we will be discussing more and more topics on Docker. Okay. Have a nice day and